Hey there, welcome to my channel. Today we're going to learn about chemical bonds. How atoms combine to form molecules. You know that if you put two or more atoms together, it forms a molecule. For example, two hydrogen atoms combine together to form a molecule of hydrogen gas, which is written as H2. In our last video we learned about the different types of chemical reactions. We learned what are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, etc. In that video we said that when two or more reactants combine to give a single product, it is called a combination reaction. But how do these reactants combine? How do they combine to give a new product? That is where chemical bonds come into picture. So in this video let's learn all about the chemical bonds. Atoms are the smallest unit of a substance which can participate in a chemical reaction. But remember one thing, atoms are never created or destroyed during a chemical reaction. This means that the number of atoms on the reactant side must be equal to the number of atoms on the product side. Consider the reaction between magnesium and oxygen to form magnesium oxide. Here magnesium is the reactant and magnesium oxide is the product. Now on the reactant side we have one magnesium atom and one oxygen atom. Similarly on the product side we also have one magnesium atom and one oxygen atom. So here the number of atoms on the reactant side is equal to the number of atoms on the product side. Now if you look at the reaction between sodium chloride and silver nitrate, here sodium chloride is the reactant and silver chloride and sodium nitrate are the products. On the reactant side we have one sodium atom, one chlorine atom and one silver atom. Similarly on the product side we also have one sodium atom, one chlorine atom and one silver atom. So here to the number of atoms on the reactant side is equal to the number of atoms on the product side. Now let's consider the reaction between magnesium and hydrochloric acid. Here magnesium is the reactant and magnesium chloride and hydrogen are the products. On the reactant side we have one magnesium atom and two hydrogen atoms. Similarly on the product side we also have one magnesium atom and two hydrogen atoms. Again the number of atoms on the reactant side is equal to the number of atoms on the product side. But when we take the example of methane, here the reactant is methane molecule and the product is carbon dioxide and water. On the reactant side we have one carbon atom and 4 hydrogen atoms. But on the product side we have one carbon atom and only 2 hydrogen atoms. Here the number of atoms on the reactant side is not equal to the number of atoms on the product side. This is because when methane burns in air it reacts with oxygen and here the number of atoms on the reactant side will be 1 carbon atom and 6 hydrogen atoms. Yes, because oxygen also has its own atoms. Here the number of atoms on the reactant side is equal to the number of atoms on the product side. So from these examples we can say that in a chemical reaction the number of atoms of each element on the reactant side must be equal to the number of atoms of that element on the product side. And this is known as the law of conservation of mass. Now coming back to our main topic, that is chemical bonds. Atoms combine with one another to form molecules in order to achieve stability. Remember in our last video we told you that noble gases are the most stable elements. Why? Because they have a complete octet of electrons in their valence shell. Let's take the example of sodium chloride. Sodium is a metal and chlorine is a non-metal. If you look at the electronic configuration of sodium we have to 8, 1 and that of chlorine we have to 8, 7. The number of electrons in the outermost shell of an atom is known as valence electrons. In sodium there is 1 valence electron, but in chlorine there are 7 valence electrons. So in order to achieve stability, both sodium and chlorine will try to gain or lose electrons so that they can have 8 valence electrons like the nearest noble gas, that is neon. Sodium loses 1 electron to achieve stability, whereas chlorine gains 1 electron to achieve stability. When sodium loses 1 electron it becomes positively charged, and when chlorine gains 1 electron it becomes negatively charged. This positively charged sodium ion has a tendency to attract the negatively charged chloride ion. And this is the electrostatic force of attraction between the oppositely charged ions, which holds them together, and this bond is known as ionic bond. Ionic bonds are formed due to the transfer of electrons from one atom to another. For example, sodium chloride, magnesium oxide, calcium fluoramide, etc. Now let's take the example of water. Water is formed due to the combination of 2 hydrogen atoms and 1 oxygen atom. Both hydrogen and oxygen are non-metals. If you look at the electronic configuration of oxygen we have to 6. So oxygen needs 2 more electrons to achieve a complete octet. Whereas in hydrogen we have 1 and we have to consider the duet rule here because hydrogen is the smallest atom and it has only 1 shell. So it needs only 2 electrons to fill its shell. So in order to achieve stability, 2 hydrogen atoms will share their electrons with 1 oxygen atom. So here oxygen achieves a complete octet and hydrogen also achieves a duet, and this bond is known as covalent bond. Covalent bonds are formed due to the sharing of electrons between atoms. For example, water, methane, ammonia, etc. Now let's take the example of methane. In methane there is one carbon atom, and for hydrogen atoms, carbon needs for more electrons to achieve a complete octet, and hydrogen needs only one more electron to achieve a duet. So in order to achieve stability, carbon shares its electrons with 4 hydrogen atoms. Each hydrogen atom contributes 1 electron to the shared pair. So here carbon achieves a complete octet and hydrogen also achieves a duet. And this bond is known as covalent bond. Covalent bonds are formed due to the sharing of electrons between atoms. For example, water, methane, ammonia, etc. Now let's see some properties of ionic compounds and covalent compounds. In ionic compounds, the electrons are transferred from one atom to another, whereas in covalent compounds the electrons are shared between atoms. Generally, ionic compounds have high melting points and boiling points, whereas covalent compounds have low melting points and boiling points. Ionic compounds are hard and brittle. Covalent compounds can be gases, liquids, or even solids at room temperature. For example, water and methane are covalent compounds and exist as a liquid and gas at room temperature, whereas sodium chloride is an ionic compound and exists as a solid at room temperature. Ionic compounds are good conductors of electricity when dissolved in water or in the molten state, whereas covalent compounds are poor conductors of electricity. Now let's move on to the different types of chemical bonds. There are mainly 3 types of chemical bonds. They are primary, secondary, and tertiary bonds. Primary bonds are of 2 types, that is ionic bonds and covalent bonds. These primary bonds hold the atoms together very strongly. Secondary bonds are weaker than primary bonds. Hydrogen bonds and van der Waals forces are examples of secondary bonds. Tertiary bonds are the weakest type of bonds. Now let's see what is electronegativity. Electronegativity is defined as the ability of an atom to attract a shared pair of electrons towards itself when a covalent bond is formed between atoms. If the difference in electronegativity between 2 atoms is large, then the bond formed is an ionic bond. If the difference in electronegativity between 2 atoms is small, then the bond formed is a covalent bond. Now let's see what is a polar molecule. A molecule in which the electrons are shared unequally between the atoms is called a polar molecule. For example, water. In a water molecule, oxygen, being more electronegative, pulls the shared electrons closer to itself. Hence, the oxygen end of the molecule becomes slightly negative, and the hydrogen end becomes slightly positive. Now let's see what is a nonpolar molecule. A molecule in which the electrons are shared equally between the atoms is called a nonpolar molecule. For example, methane. In a methane molecule, carbon and hydrogen have almost the same electronegativity, so the electrons are shared equally between them. Hence, there is no separation of charge in the molecule and it is a nonpolar molecule. Alright, so that's what we were going to learn in this video. Make sure to watch our next video. Until then, goodbye.